This is the Illinois Nutrient Loss Reduction Podcast, Episode 29. Meet the new Illinois NRCS State Soil Health Specialist. I'm University of Illinois Extension's Todd Gleason. Well, the Natural Resources Conservation Service in the state of Illinois has created a brand new position called the State Soil Health Specialist, and Stacy Zuber is its first occupant. I asked her to tell me a little bit about her journey to this position.
I am from Illinois. I grew up in Southeast Illinois, near Olney, Illinois. Grew up on a corn, soybean, wheat farm, so I have a little bit of that farming experience. My dad still farms. And then I ended up going to grad school at the University of Illinois here in Champaign, and did some research in Western Illinois looking at long-term crop rotation and tillage, and how those practices can influence soil health metrics. And so I got to work there with some Illinois soils. And then after I finished grad school, I went east and I went to Purdue University, got to work in Indiana on a project with the Conservation Cropping Systems Initiative. We did on-farm research with some of the commercial soil health tests. We looked at how sensitive those tests were to different management practices. We looked at cover crops, we looked at tillage, some other things as well, but those were the main ones that we focused on. And then I went west to Missouri, and I was at the University of Missouri, and again, worked with some soil health data there. They had a project that was a statewide cover crop cost share program, and as part of that, farmers would send in soil health samples that got analyzed, and I got to work with that data set. It was over 5,000 different fields, soil samples from those fields that we were looking at, and we were able to really see for these different soil health metrics how the inherent soil characteristics influenced those measurements, and how the management also influenced it. So I've kind of had a chance to work in some of the nearby states as well as in Illinois on soil health, and so with this position, I'm really happy to be able to be back in my home state, getting me to apply some of the things that I've learned in other states and how they have worked with farmers and with conservation partners on soil health and increasing the adoption of soil health management systems.
So can you tell me a little bit more about these soil health tests and exactly what they measure or are supposed to try to measure?
Yeah, so they're trying to measure the soil function. So when we're talking about soil health, everything to do with soil health is really focused on how the functions are happening. What are the processes happening within the soil? So these different soil types kind of look at different aspects of the soil and how it's functioning. So soil organic matter is the one that most people know. It's usually included in your soil fertility test. So that's really important. It's very closely related to almost every soil function. But it can take a number of years to change. So a lot of these soil health tests are supposed to be more sensitive. We're trying to see those changes in a shorter period of time, in maybe 1 to 3 years instead of 3 to 5 or longer that it might take to see changes in the soil organic matter. So some of those are like active carbon is a measurement that looks at a specific portion of the organic matter. That's the part of the organic matter that's decomposing that microbes can use as a food source. So that's a good indicator within 1 to 3 years that down the road you will see improvements in your soil organic matter. You will see increases in the organic matter in a few more years. You're not seeing it yet in the overall pool, but if you see those changes in active carbon measurement in a shorter period of time, you're going to see the bigger changes in the organic matter down the road. And then there's other ones relating to nutrient cycling. We have things like soil protein that tells us the nitrogen that's stored in the organic matter, most of that's stored in soil protein. And then as microbes are able to eat those proteins, then that nitrogen gets mineralized and gets released in available forms. So they're available for your crop to take that up. So we can look at the nutrients there. And then I think one of the most important metrics that's out there is aggregate stability. And that's one where it tells us about the structure of the soil, and it can tell us if that soil is able to resist erosion, and it also tells us about how well that soil can have infiltration of water, how well that soil can store water as well. Because with soil aggregates, basically we have all these particles, mineral particles within the soil that are held together with organic matter, kind of acting as the glue, holding them together to form these aggregates. And around those aggregates, you have pore spaces, which is just openings where you can have air and water moving through the soil. So if you have good aggregate stability, you have these aggregates that stay together and resist breaking apart, then you have those pore spaces for water to be able to infiltrate. And it can be a sign, if you have poor aggregate stability, that you may have compaction issues because your soil particles may break apart and start sticking together very, very closely, not leaving any pore spaces behind. That can also lead to problems with ponding of water when we have these heavy precipitation events, because now there's nowhere for that water to go in. You can have ponding, or that can also, because you have reduced infiltration, that can lead to lots of runoff. And with that, now you have these loose particles that can erode away and leave your soil surface. So, those are just some of then there's many, many more indicators out there that are available. But most of these are available from many different commercial labs. And I think those 4 that I mentioned are kind of the ones that I think if you're going to look at these tests, those are the ones to start with.
So I'm going to put this relatively bluntly, but just because as you listen to it, you might be thinking to yourself, "Oh, cool for you because you're a scientist and understand it all." But you do think that this is useful, and the producers might explore it as well?
I think it can be useful, but I think it has to be used properly. You have to do some extra things for soil health tests differently than you would for soil fertility tests to really get the bang for your buck, so to speak. I mean, they are more expensive tests. You're talking somewhere, the cheapest ones, if you get them individually, a lot of times are at least $20 a test, up to $100 or $110 a test. So they are quite expensive. So you really have to do everything exactly right every time you do these tests so you can get valuable information. And that's tricky because these tests, a lot of them are focused on the soil biology, about the soil microorganisms, and those microorganisms are very patchy within the field. There's a lot of spatial variability. Sometimes, a lot of the times they're really clustered in certain areas. So you have a lot of them around plant roots. You have a lot of them near the soil surface. You have them in pore spaces, but not in the inside of aggregates. You have these different areas where you have lots and lots of these organisms, but other areas where it's basically a desert. There's not very many of these microbes living. So you have to be really careful that you're getting consistent conditions every time you're sampling. So I think the 2 ways you can use these tests are to compare very different management practices. Let's say you're comparing a conventionally tilled system with corn soybean with no cover crop. You want to compare that to a no-till system with cover crops. That is a great way to use these, but you have to make sure that the soils that you're comparing are very similar, that they're the same soil type and the same landscape position, because if those are different, you're going to get different results regardless of what management practices you're doing, because the soils are so different. So that's one thing. But then the other way that you can use these soil health tests are to monitor over time. And I think this is probably the biggest value for most farmers, is to be able to look at these soil health measurements and look at them. How are your soil? Is your soil changing? How is your soil health improving over time as you're using these conservation practices? But with that, you still have to be careful that you're being consistent. And so, I mean, I would recommend that you do these tests, if you're going to monitor them over time, every 3 to 5 years. You don't need to do them more frequently than that, because you probably aren't going to see changes that rapidly. It's better to do it every 3 to 5 years, but that's a lot of time in between there. And I don't know about anyone else, but I can't remember every exact detail of what I did if I'm going to go out and take a sample one time and then 3 years later expect to be able to get it to match up. So it's really important to write down all the details about what you did when you sampled so you can match it up. So what time of the year it is, what's the soil moisture like, how, even something as mundane as how close to living plant roots are you taking the samples? Are you taking them right by your plant roots? Are you taking them kind of in the middle between your rows. When was the most recent tillage or fertilizer, or when was the last time that the soils were lined? All of those things can really influence the soil biology, and since that's what you're measuring, you really need to look at those and make sure you keep them as consistent as you can, or at least be able to know what they are so you can think, well, maybe the reason why I'm getting lower results this time is because I recently fertilized. Maybe it was that instead of the fact that your soil health went down. It might not be that. There might be something else to explain it. But if you don't write these down, it's really hard to know. You need to have as much information as you can so that you can get as much value out of these tests.
And finally, you are the first State of Illinois soil health specialist with NRCS. Do you know why the position was created?
I think there's more and more interest in soil health over the years, especially recently. And there are several states that have already had this position, some states that even have, multiple soil health specialists within their state. But I think for Illinois, there was one of the driving factors to this was there was this big national push from the national headquarters of NRCS to do more things with soil health, for each state to develop a soil health strategy. So I think this was the perfect time for them, where they were already looking at trying to put this position in place. But then because of this national push, it was a little easier to justify why we needed it. And I think it's, the soils of Illinois are amazing. They're some of the best soils in the world, in my opinion, in this state. And I think it's really important that we protect them, that we improve them. So I think it was a great time to do this, to have this position put in place and have a person on staff who's specifically dedicated to working on soil health.
Stacy Zuber is the very first NRCS state soil health specialist in Illinois. She joined us here on the Illinois Nutrient Loss Reduction Podcast. I'm Extension's Todd Gleason.